So today we are going to solve the heap related problem, right? So the first problem is like the mm, mm, kth largest element in array. So this is related to the heap problem. So we have to use the priority queue, right? Maximum priority queue or minimum priority queue. Although we can solve using different like a set or multi-set or the map, but we have to generally solve use priority queue. So what the question suggests that given that integer array nums and integer array nums and a integer k, return the kth largest element in the array. So how can we do? First you can brute force approach like the sort and then return to kth element, right? First like the what I'm trying to say, like first the sort nums dot array begin and nums dot range, right? And just return the nums of k minus 1, right? What? Okay, sorry. This is the simple brute force approach, or what? If it is not, then how can we solve using the priority queue, right? The question arises from this. So what we can to do? We have to use 3, 2, 1, 5, 6, 4. K is equal to 2. Now we have come to 5. So what can we do here? We can use the priority queue. What priority queue? Right? The minimum or maximum. So we can use here the minimum priority queue, right? Right. How can we proceed? Use the- Like we can use the priority queue. So let's understand. First, let's take a site, right? Now the priority queue, what priority queue in, and I think we have to take a vector, right? What the priority queue and the greater. Sorry, I think this is the priority queue, right? Priority queue, priority queue, priority queue will then where each element associated with priority ties to minimum min heap. So how to the priority queue? Okay. So in C++ massive vector int and it. Yeah, this is the syntax of the min heap and this is the max heap. So I'm trying. I think I do right. This much, this right. So now let's suppose 4 int and int and plus. So pq dot push. What we have to do? Push nums of I, and if the pq dot size, if it is increased, then k, we have to just pq dot pop, right, and just return the pq dot pq dot pq dot top. So this will return the minimum, right. This will return the minimum because I use the priority queue of minimum. If the size is increased, okay, we have to pop back. This is the question. Now same goes to this question, right? Just we have to use here the maximum heap, right? There I used minimum heap because I have to find the smallest largest element. But here we have to find the kth smallest element, so we have to use the minimum heap. How can we use the minimum heap? Like from here, let's suppose from this 10, say 1, 4, 3, 20, 15. So this much 10, 4, 10, 11. This is the 3. Now just insert 3. So it's 3 out of bound. Sorry, 10, 7, 4. So the 3, the 3. If it is 3, so 5, 7, 10 is goes out of bound. It's 20. So 20. So again 20 is out of bound. Now 15, 15 is outside. So just use the priority queue of maximum heap here, right? So what we have to use? Just priority dot size. Now pri priority 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 queue and PQ. Now just we have to just move just PQ PQ dot push, push array of I if the PQ dot size is greater than k, then we have to just remove, right, pop back, pop, not a pop back, and just return the PQ dot top. Yeah, let's try to submit it. Yeah, it's submitted. Now let's move the next question. So k sorted array. What we suggest? Given the integer, given the array of n distinct elements, you have to check whether the given array is sorted, k sorted or not. K sorted array is an array where the element is at most k distance from its target position in a sorted array. Okay. So every element is distance away from its target position. Therefore, okay. Okay, now I understand what this problem said. Said that like 3, 2, 1, 5, 6, 4. The actual meaning, the actual sorting is 1, 2, 3, 4, 5, 6. So it's index like 1, 2, 3, 4, 5, and it's index like a so yeah. So what we have to do here, just take the with index, right? Just take the sorted array like input, like 3, 3 with 0, 3 with 0, 3 with 0, okay. So 2 with 1, okay. Mm, it should be it should be present like a here we have 0. What we have to do here? Mm, Just see if the difference between just sort with the pair, right? So we can use the here priority queue. What? So the question is what priority queue we are going to use. Let's see from my perspective what might be the solution. Case for two. So like if we are store 3, 3, it's a good. Okay. Now let's come to 1, 2, 3, 1. No, 1, 3. Okay. So it's come 1, 3. Yeah, you can use the priority queue, right? What priority queue? What? How can you we use priority queue? So like a pairwise. Yeah, you can use the priority queue like a pair maximum, pair minimum. Sorry, priority queue, 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 pair in vector pair, pair vector pair in and the greater pair int and int. Right. So now what we have to do? I have to just travel through the array and just push pp dot push what area of I and I. Now take a int 0. Now 4 should be give me whether the space sorted at which where distance at most I plus 0. Sorry. While PQ is not empty, we can check out like uh, like original index for index would be pq dot top dot second and pq dot pop. Now if the absolute distance, can I say, yeah, you can say minus original index is greater than k, just return false. else return true. Just increase the size. Try to give into valid argument template. But so this is not the priority queue if we using the array pairwise priority queue, pair priority queue. So what is the syntax? Like, I think this is right. Pair vector std pair. I think this is right. Or anything and the greater pairwise mean right. What is this? Have I made any mistake? Okay, yeah, I made a mistake. Why this? What? Bool value could convert false from the bool value false. Okay. What we have to? Yes or no return done? Yes. Sorry. No. No. And this we have to? Yes. Right. This should pass the test cases. Yes. So now let's move the second. Let's see the other solution of mine. I like what I do. Yeah, same approach I use. Let's see the other solution of comment. Is there a better solution than mine? No, I think all use mine solution, same approach. So this is one. Now let's move the next question. My the case sorted list, right? And my the case sorted list. So what is this? You are given the area of k index k linked list, and each linked list is ordered in a ascending order. Okay. So one I got it. 1 5 3. Okay. Now next 1 3 4. Okay. Next 2 6. So one this. Now we have to move next. We have to move next with this. So 1 6, and we are here. Is there all are connected? Yeah, I think so. We have to just move it out. Right? We just take a priority queue and store all the list values, and again we can build a list. This is the brute force approach, I think, right? So what I'm trying to do, like what I think, sorry. Now what we have to do, let's suppose take the list in a vector or just sort them all and again build a new linked list. This might be the one solution. And if we think how to do with the approachable way, like the optimal way, So how can we proceed? 15326. Disconnect to all. No, no, disconnect the not solution. Right. Okay. What we have to do here? We can use the vector. Just I solve it using the vector. Let me show you. Right. So I solve using the priority queue like this. First of all, I travel all the list and push all in a priority queue. Then again, I am built the list and the return. So this is the one type of a brute force, not an optimal way. If we think about optimal way, how can we proceed like this? So this one is good. You can use the priority queue or array. You can use the array, right? So let's see the other solution that how it's solved. Merge two list at a time. Okay, merge two split list at a time. Okay, that means we have to merge this. Okay, then again this. Okay, so this code merge 27. Let's see the how it is built. It merge list. So it's merges temp new. Okay, list dummy. Okay, okay, okay. So where is the call? This function is called like yeah. Yes. Merge list. Oh, just like we can use the here brute force like take a vector, one temp and travel all the list like lists while we have x we temp dot push back x dot value na well and x dot x and next, right, and just take a dummy node list node, just sort temp dot begin temp dot in, right, this and make a new node equal to new and the list node and 0, right, or what we have to do, just make a list node add equal to new node and let's just travel. Let's just travel all the list temp dot size, right, temp dot size and new node next is equal to new node list temp I, right, and just return the header next. This one is one solution. Video in lean. Okay. So this one is quite, so this one list not a list not okay. Yeah. Now we have to just see that. Oh, sorry. Just we have to move the notes, right? There is the wrong answer. Why? Only six? Why? I next. Okay, okay, okay. We are not moving. We will not equal to mu not dot next. We are not moving, right? We have to just traverse now. We have to just go the English. You can solve it using the priority queue, right? So if you use the priority queue, let's suppose we use the priority queue, queue in vector in and greater in them, just push them and just what, just use here while. Okay, pt dot pt, not pt. So pt is equal to pt dot top and pt dot top. Pt. So this might be the one case, not a, just use the term. So this one. So if you use the minimum priority queue, this give you chances like sorting element. It's, so this is like a brute force approach, right? If you want to optimal, you have to check out this. So this one. It. Let's move the next question. I solved this and replace element by their rank. Okay. Replace element by their rank of the type. Okay. So you are given the array of integer. Task is to replace each element of the array by its rank in the array. Okay, the rank is defined as the distance between the element with the first element of array. Okay, so it's a zero. Okay, no, 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 not zero. Just you have to just first find the first element of the, right, like 20, 30, 62, 96. The distance between. So you have to just find 20, 20, 26 to 96 and 4. 1, 2, 3, 4, 5, 6. So it's like 3. So it's like 3. After sorting, area become like a, area become like 4, 6, 8, 9, 15, 20, and 26. Right. So what we have to do now? Alright. Okay, sorry. How important is HEAP for freshers? Do they ask for the campus? In campus. In campus. In the campus, I don't think they ask, but the off campus they generally use. And for, for solving the question, I think priority queue used like priority queue I solved in my CP journey like custom custom priority queue, and also for like what for finding the sub-array range where I use the priority queue, then maximum or minimum priority queue. So for the campus, in the campus, I believe it totally depends which company or the which the tech industry in the college come for the interview or job. So we have to just in this question we have to just what sort the element, right? And we have to find the rank wise like 5 6. Now after sorting area become this like this 2 5 6. Okay. 2 5 6 0 1 0 1 2 3 and 4 like 2 6 15 20 and 26 or 98. Right. So it's like a its rank is like a 33. It's 4 and its rank like is 3. So it's just you have to sort, right? What what you had to do? Sorry. Mm, So how many important is the issues that they are rank? Like, what we have to do here? Just sort now. Just sort. How can we sort it? Like if you use the priority queue, this help you to like first. So let's suppose let me clear out suppose one. So let's what I'm trying to do. Let's take a n. Oh, n is already present, so we have to just note it. Let's take a answer variable, right? What is answer variable? So it's n. Now let's take a priority queue. What minimum priority queue, right? Priority queue pairwise and the vector and the pairwise, right? And the greater 2, 3, and 1. Thank you, right? Now what we have to do, just insert all the right, and then just insert pq dot push what element with index, right? After sorting it become like a sorted array, like a 1 with index here, 2 with index, 3 with index. Just you have to take it down of their rank. Now what we have to do? Just pq dot push pq dot empty. Now let's take the rank is equal to 1. Now what we have to do? In the element into the index should be pq dot second. Index is present on pq and second. Just pop back pq dot pop back and put index I is equal to rank rank. I think rank. Sure. Yeah, rank plus plus. Just Just return the answer. I think this is good. Good to go. What pk dot second? Oh, sorry. pq dot top dot second. pq dot second. This is the given the right answer. Let's see if it passes all the test cases. Okay, so it's fail the test cases. What is the fail? Why? So it's like a 20, 30, 40, 0, 1, 0, like 1, 6. I forgot. But I'm trying to something right. What is this that is giving? Like one is good. Like if we start with it, 2, 3, 4, 2, 3, 10, 2, 3, 10, 14, 14. Okay, 14, 14. Why this? So this said that if the element is if the element is present, so we have to just take it out. -1. Just initialize -1. So what? You can't go like so you have to just put it out like right. Uh, can't remove that right index. So what we have to do? So if we take -1, so it's become the rank 1, rank 14. If it is find again, so we have to just not increase the element, right? So what we can take here, we can use the map data structure or the, let's see how much. Yeah, you can use the map data structure here. mp visited visited, right? So if the mp dot found, that means the it is present. So what is present? What is present? Element. Element. What is element? pk dot top dot first, right? This is element. If it is present, element is present, just take the answer I and dx is equal to element mm, answer mp dot element, right? Else if just just answer idx is equal to mp dot, sorry, rank plus and the mp dot, not a plus but a rank, and mp dot element is equal to rank and again rank plus. So this might the while pq while okay, sorry, not it. So we use mp all time na. So just use the mp all time. So this giving the right solution. Let's see if it passes all the test cases. Yes, this passes all the test cases. So you have to just see that. Let's see other mine previous solutions I solved. Yeah. So I use the priority queue, minimum priority queue, and sorted. Now I sorted like if the element is find previously, so we have to rank. Otherwise, we have to increase the rank +1. Okay, and rank can increase and find the element of first. Okay, okay. So this is the good approach. Now let's move the next question. Task scheduler and the hand of a state. Right. What is task scheduler? So you are given the CPU task is labeled with the letter A to Z and the number of n. Okay, number n. Okay, this CPU interval can be idle intervals can be adults and allow the completion of one task and can be completed in any order. Okay, there is no constraint. Okay, so there is gap. There has to be a gap, at least an interval between two tasks with the same level. Okay, A and B. Return the minimum number of CPU required to complete all tasks. Now I get it. Why this thing? Like we have A, B, 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 right? In the first case, like 3A and 3B, and the n is 2. So they said that the gap should be at least n interval. Okay, so if we solve this in the interval, next interval we can solve this. Okay, A, B. Now, if CPU can be idle or allowed to completion, can CPU interval in order. Okay, again A or B. Again A and B. Now, in this question, what we have to do? In the fifth question, right, we have A and A, C and B, that means 2A and 1C and 2B and 1D. So what we have to do here? A, yeah, B, right? Now C, A, B. Okay, now D. Okay, this 1, 2, 3, 4, 5, 6, 6 interval. So now what we have to do here? Now what we have to do here? This much is good. Now this one, like 3, okay, and 3. So its interval is 3. So we have to use, we can take in one slot different. A is equal to 3, B is equal to 3. So we take one and the next, so next, what? Next element should be come to like 3A, okay, 3B, okay. So now let's suppose A first come, now it's become 2, now it's become 2, so it's become 2A. Now let's suppose 3, so it's a 3, now it's become again it's come to A. Now we have to just check, what check? Like how much distance previously, okay, take A, now take B, okay, 2, B, now I take idle, task scheduler. That means we have to take a minimum number, right? So if you want to take a minimum number, you have to just do what? First we take to the A, okay? So it's like a, first we take A, now next to take B, there is nothing, we have to take A, but the distance between and A and 3 is less than, now it's A, so it's not. So not for, take take one again, increase the and remove this. Can I? Yeah, you can. Can I now take it? Now, yeah, you can. So it's like 4 and the idle, idle, okay, idle, 4 or idle. Now, can I use the priority queue? Yeah, level wise priority queue. Yes, you can use. Yeah, of course. So A, B, Now how? A A को पूछते हैं A कुछ किया कुछ किया A now now can I take B? No, you can't take B. Yeah, you can take B. How can we approve like this? Particular like A like approach like writing Q394 out and 1. If you use the normal data structure, writing Q like rest we have to find like 1 1 1 1. So we have to just find the data structure like so then how can we prove use the practice many list interval? Okay, just we have to use like how much this come like A come the 3 times. Yeah, 3 times, 3 times, 3 times. Now we have to check to the problem. Good problem. Hmm. So what we have to do here is count the 3 times, right? So it initialize the one, then the next initialization which come with 1 plus 3. What we have to do here, let's suppose we have 3A. So what we have to do? Let's suppose we initializing A with 0. Now next initializing with 1 plus 2. So it's take like what? Next initializing with the will be where? A. The next initializing will be in place of 3. Again the next initialization should be 3 plus 0. Then B. Next initialization B. So that's the maximum answer is the solution. Right. Right. What we have to do? First, we have to take. First, we take. You count the element, right? And the cycle should be n plus 2, right? So what we have to do? Take a map in ratio frequency for counting the frequency for auto x x and tasks. Now frequency we have to frequency like x minus a or not a plus plus. Now take the priority queue. What priority queue? Maximum heap priority queue. Right. Take up maximum priority queue. Now let's store all the priority, all the 26 letters frequencies if it is present. If mp dot count I, then we have to just push mp dot I, right? So it's rotate sort all. Now we have to what to do. While wiki dot empty, sorry, empty, where we have to initialize, like how can we initialize like taking the cycle. Let me first just confirm from this test case. Okay, so we have a is equal to 2, b is equal to 2, and the c is equal to 1 and d is equal to 1. So a, that means we have to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That like this. So we take a, now take a, we take b, now we have to take b, now we have to take c, now and d. So it's like a 5, it's like a 6 answer. So what we have to take a empty index, right? Take a empty index, take take a empty index. So it's like a more like a it's more like a consider, take a empty index like a what? Uh, mm, so what supposed to do? What we have to do? Like first of all, take the maximum frequency f peak dot top, yeah, and peak dot pot, sorry, pop, yeah. Now we have to move from the k to k, right? What k to k? Like from the empty index, from the I empty index, empty index, you have to go, you have to go, you have to go where? You have to go like from the empty index, you have to travel like a from the empty, you have to travel how much distance should be for that? Like if you are 0, so it's like a 2. Sorry, it's a 0, so you have 0 plus how much distance? 0 plus 2 into 3 distance, है ना? 3. So it's like a 6. Proceed to 6 distance, right? So it's like a 1 plus 2 into 3. So it's like a 7. It's a 1. So 1 plus 1 index, 1 plus index, 2 into 2 into 1 into 3. So it's like a 4. 1 and 3. You can go like a 3 distance out of the main, out of the box. Now you have to take like, so just what we have to do? Just travel now. What from the empty you have to travel k plus one till the empty x is not empty. Okay. Right. While and max mean time, right? 0. It's going to max, right? Empty empty plus, okay. So it's frequency minus minus. You have to just take the empty slot, take empty empty slot, right? While empty is not empty, so you have to just empty. You have to take a something good, like take a remaining vector, remaining, take a remaining, or what we have to do? If you use the like what we have to do? Like what cycle should be? What cycle should be? N plus one, right? Mm, just traveling, just pushing all the frequency remaining element. Just take a maximum, right? Just take a minimum, like 3 3 1 1. So it's taking three. We're traveling, we're pushing. Next frequency is three. So three. Now go back. So it's like a three. So it's a two. 3 2 1 1. And cycle plus plus. Time plus plus. Just what we have to do here. mm, Nothing much. Just initialize, right? Just initialize. Just, 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 just give all. Right. Just give, just give pk dot empty. It's same like a and cycle now, right? So max frequency we are taking pq dot stop and pq dot pop. We are removing it. And if the max frequency is still still present, so we have to take in a remaining pushback max frequency minus one, right? And increase the timer and decrease the cycle, decrease the cycle, right? And again, after coming out from this, just iterate through the remaining, remaining, and pq dot and pq dot push what x. So this and return the timer. This is great. And timer, timer plus plus. And if the mp dot pq dot empty, right? Just break it out now. Empty, empty, empty. Break out. Why? And timer is plus plus, right? And the cycle. What is timer? So what is mp? Frequency, frequency. It's like a brute force approach. Like, what is cycle? Okay, what is cycle? Then this is cycle. This solved. So I solved it. Let's see the previous solution of mine. So I use the first and sort with the, and sum with, and so this is the solution of formula based, right? Just take the, like the ideal sport we taking, how many idols should we put there, right? Because of the maximum value I taken. This is now first solution I passed. Similar, same this formula based solution. This is all the formula based solution, and this is the brute force approach, which I solved with this. This is like I use CP scheduling here, CP scheduling algorithm, taking, removing, and then again storing, then again traveling like this. And the question arises that why this cycle ended. So if the time cycle is not a zero, we have to add now, because we have to gap at least n plus n. So we have to add into the gap. That's why we are taking here. Now let's see how can we solve using the formula base. Like, let me first take it out. Like 3 3 1 1. How this, like this generally takes you the idle source and into the result process. Like 3 and 3 and the, how many idle store? One? No. 1 into, like 1 into 2. Two idle store. One idle. Yes, this much idle store. We can fill here. Next. So idle store is good. Now just you have to just initialize how many. You have to just give, like here, इसको कितना पड़ेगा? टाइम है, टाइम जिस स्पीड में टाइम है, 3 सबसे ज़्यादा 3. So it's like a 3, and it's like a 3. So 3. It's like a 3 in that. So we have to just take 3, 2 plus 3. So that's where we can go 3 into 3. So it's like a 3 plus 1, 3 plus 1. We have to take like now. How to approach? Let's see the solution of others. Either static queue approach, relate, math, maximum here. If you said during a frequency, remaining frequency hit, what is it? If you educate wait to interval during again CPU dealing, So this is so much. Yeah. Gratitude, character wise, frequency, the maximum hip. Okay, same approach. Just like I used the cycle, mistake cycle, and the frequency element, and the cycle, and I store the cycle, and the state cycle plus one. Same approach. Not a not a good. Maximum. Let's see the other solution. Anyone provided the best similar. I solved this like a good first, like a see here. See here. Like first we have to find the idle state. So from the maximum frequency we can find uh, how many how many spot is vacant in all the cycle. Right. So in the first cycle we have to, let's suppose, and the second cycle we have to, and the third cycle we have to. So it's now it's uh, so it's like a thing we have to. I don't know anyone for result I. So result I should be right now. Result I should be. I think the two. Now four we have to do. Just just we have to do like three three two one one. So it's like how many distances? It's like a two distances in between. Cycle. It's idle sports now. You can take the take a B and C B. So it's like a it's like a page, for example. We have to just add the S plus one. So it's like a one into two. It's like a two step, two, two, two position idle. Okay, now let's move to the next question. Cycle is one plus one, right? Now let's move to the next question. It's all right. So what is this question suggest that Alice has some number of cards and she want to rearrange the number into groups such that each group size, okay, has a group size and consists of group size of consecutive cards. Okay, the given array has there is the value written on I card and the integer group size is written. Return true if we arrange the card or the priority or the false otherwise. What? What you have to do? Just use the priority queue, right? And upstairs. Like for one, so what can we use? One, just remove from the one, use the three, just now we have to first three, four, remove. Take into priority queue at minimum priority 1, 1, 2, 3, 3, 4, 6, 7, 8. Now let's take a 1. From the 1, we are traveling like the three group. So 1, 2, and 3. Both are present. So just remove from here. We are removed from the this one. Now let's come the 3, 2, 1. Now 3, 4. So it's come. Now let's move. Now let's come the second one. So what we have to do here is to use the like the you can use the binary like you can use the priority queue, minimum priority queue or the set. I think best way to use the set, right? Because it provides us to hand dot begin and hand dot end. Right. Now what we have to do? Just take while 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 empty dot empty empty dot empty. Just take the just take element like empty dot begin. Okay, begin and empty dot erase. What? Empty dot find empty dot begin. Now just II is equal to what? Just remove this. No, no, no. Just copy from here and just what? Good. Element. Element. In the element. Element. And II is equal to group size. Group size should be 3, right? Group size plus plus and paste. Just 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 do just do what? If empty dot count 11 11 II and not just return the false here and just empty dot erase empty dot find 1 1. So let's see if this passes all the test cases or not. I think this should pass the all the test cases. Let's say time limit exceeded. Is the time limit exceeded? What? I think this should pass the test cases, right? What is the group size? Hand size. It's why this giving the TLE. Why this approach give the TLE? Let me see from the priority queue. We have set, we have primary queue on the multi-set. We find the maximum. Why TLE? We don't count in the zero. So it's like a what? Element plus right? find, just find, right? Just also IT empty empty dot find II. If the II, if IT is empty dot end, just return false, false. Else empty dot erase IT. Right. This should not give the tag clearly. I think so that yes, it passes all the test cases. Yeah, this is the multi-set data structure. So why this giving like why this giving not a good one? Because like for using the count, so for find using the count, duplicates may present and if the duplicates is present, so it's basically check all the duplicates, right? So that's why. Same question is present here. The cake and GT set of, and I solved using the. I think I solved using the this problem. Various, yeah. I solved using the this one. What is this cake group search? First of all, using the priority minimum priority cake. Like I solved using all the frequencies, using the frequency, and this one I solved using the map. So which one is both is good? So you can use all right. So now just see if the size is not, so you have to just use try to move just take a plus a, right? A plus a plus k should be less than like 1, 3 plus 1. That's it. We are increasing the frequency with the frequency is 0, so we have to just remove it. And if the frequency becomes the 0, just we have to pop back. Just I'm using extra in this priority queue. If you use the priority queue, you have to use the extra space for the map. But if you use the multi-set, you have to just use multi-set bus only. This is the only difference. But you can use the priority queue. This is the same problem. I think they said. Given the area of number list, check whether it's possible to divide into k consecutive number. So I think this is the same problem. So let's see from let's solve this problem using the priority queue, right? Let's see. So int n is equal to nums dot size. So what we have to do? Like if the k is not divisible, right, by n, sorry, n is not divisible by n, so there is no doubt it's written the false because in dividing the kth size, you have to need 4, 8, 16. That means the multiple of 16, right? The size of you have to need the size of the element should be multiple of 16, right? So this one. Now let's use the priority queue. Priority queue. What? Minimum priority queue, right? PQ and use the one unordered map and let's see frequency. Now store the frequency of each Nums. Now what we have to do? Just to travel all the map, frequency map, and put it, push, not a push, what? What push? Frequency? I don't think so. No, no. You have to go. Uh, yeah. Map. Then what we have to do? Second, x dot first, not a frequency, but the element. Okay. Now you have to use like the whole right. While PQ is not empty, right? In what? What we have to element element PQ dot top and PQ dot pop. Now just use int element plus k and element plus. If the frequency of II is equal to 0, you have to return the frequency. You have to return the false because we can't make. And if it is present, you have to just minimize. And the while pk dot not empty and the pk dot pk dot and the not empty and the frequency dot pq dot top is 0. You have to just pq dot pop back and just return true. What? X dot MP. Okay, sorry, frequency, right? Frequency, not MP. Yeah, this also parts. This one passes all the test cases, right? Yeah, this is. So this much I solved all today, and for the tomorrow I saw going to solve these all. Right. Now let's remove this. Let's see the today POTT problem. Partition area. So what this problem said, you are given the integer nums and pivot. Rearrange the numbers such that every element less than pivot before before appear before every element greater than the pivot. Okay. What? Okay. Okay. So every element equal to pivot appear in between the less and greater than the pivot. Consider the element represent and the relative order of pivot. The relative order for element less than pivot and the greater element must be maintained more formally. Okay, समझ गए? Okay, now I understand. This is a very problem. What we have to do here? What what is the time? Okay, so time is like how much time? 135. Okay, so let's see how can we approach this pivot element like 9. Okay, so thing here is 10, 15, 5, 10, 14, 14, 3, and 10. Now we have 10, 10 simplified, so it's 9. Less than 5, so less than 5, so just, just increase the size. Now greater than 5, greater than 5, just say 9, okay, 9, 9, 5, 5, 5, 3, 3. Just if you're thinking about the brute for suppose, so we have to just take 5, 9, 3. Okay. Now let's suppose equating all the equal element 10, 10. Now taking the 15, 14, 14 and 15. So this one is a good one. So let's suppose if we thinking about the brute force approach, like in first lesser, lesser, equal, greater. Now auto, auto, sorry, for loop, auto, x, x, nums, if x less than 5, nums, sorry, lesser dot push back x, else, else if x is 5, then equal push, push back x, else just what greater push back x. This now let's take one answer, right? What might be the answer? Like auto in lesser answer dot push back x. Now for auto x greater, greater answer dot push back x. Now for lesser, sorry, equal, 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 x greater answer dot push back x. Now just return the answer. This is the common. What? Okay, facts. This is the one type of brute force approach. I think this can be fast. Yeah, this is fast. Now let's see the another optimal solution. How can we optimize it? Like if you use the double pointer here, so it's like a one pointer here, one pointer here. So if it is now 12, 5, 10, 14, 3, 10. It's here, here. Like we take middle here and the pointer here, middle here, pointer here. So just like this, it is 5. So it's increased, both increases. So it's like I here and mid here. So it's not up. So we can just swap it out. Just swap it out. This is not going to sort. This is not like one problem is like I remember this let's sort 0, 1, 2, 3. This type of problem, but here we have to sort. But here we have to sort according to the pio element, right? Here all we have to just to sort element. That's why we use a like the 3 pointer approach, right? 3 pointer approach I use, but here we have to choose the pivot element, right? So what we have to do here? First, you have to do what? 9, 10, 5, 10, 12, 3, and 10. I here, made here, so it's not month, mid, London, Paris, plus, 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 mid plus plus, all this, multiply, just remember short here, yes, again, yes, again. Now let's move to the next question. Here, again, here. If intermediate is 10, because negative plus plus. This is not going to happen. This is not going to sort, right? Because this already said that the priority should be made. So how can we sort using this? Let's see the solution of others now. Anyway, priority with vertical branches using 2 pointer. Yeah, 2 pointer. How can you solve? Like right, left, and again, right, left. Okay, this one is good. So how you solve? Like num is fired, so left ni. Okay, ni. Now if I so right ni. Okay, else just how? Okay. Now I get it. Now got it. Okay. No. No. What? This is not the this I solved. Let's see. Like 9, 15, 5, 10, 14, 320. This. Now let's suppose this is 9. So 9 plus this. Now let's suppose this is not this. So just come back. Just just go here. Go here. Okay, go here. Now what? Now so it's this. Now it's this. So we have to just 40. Now just this. So just 5. Okay. Now just so this. We have to put it out like on the left. This is left. On the how this supposed to work in, bro? Like mm, left, right plus how this is work? How this is working? Like we have 9, 5, 3. Okay, left, right, I, and JNS. Now I got it. This one is also good. So that's it from the today. So this one can solve it. So thank you. So thank you. Thank you for watching this. Thank you, thank you, thank you, thank you. Thank you, thank you, thank you, thank you. No subscriber.